Do you feel like you are always on? From app notifications on your phone to the ubiquitous virtual meeting, I know I feel like I'm always connected to something, whether for work or pleasure. But isn't it kind of crazy that the systems are always on? I mean, think about it. How often is your favorite social media platform unavailable? Better yet, how often is it that your boss sends an email late at night that doesn't actually make it to you late at night? In the systems world, we call that reliability. In the context of complex systems, reliability is the probability that a system will perform its intended function for a specified period of time under stated conditions. When it comes to business systems, this is one of the most important measures of success, and it's worth diving into in more detail if you architect, manage, or deploy complex systems, including information systems and cloud computing platforms. Any discussion about reliability begins with a little math. We'll start with the basic reliability formula and build from there. Reliability is often expressed as a probability between 0 and 1, where 1 means 100% reliable. It's calculated by dividing the number of successful operations by the total number of operations. Using operations is the most general definition, and it's focused on the actual outcomes of the system. Basically, if an operation needs to happen, what is the likelihood that it will? This gets more complicated when we think about it in business terms. For example, a payroll system that sends out electronic checks twice a month only needs to be 100% reliable when it's processing payments twice a month. The rest of the time, no one is likely to notice that the system is even there. But if my paycheck doesn't show up in my account on time, that's going to be an issue. The main takeaway here is that reliability as a systems concept matters a lot, and that as a measure of the probability of success of an operation, it's critical to business systems. If the word reliability comes up in a conversation, it's almost always accompanied by some nines. You might hear about 5 nines of reliability. What does that mean? Well, let's decode this industry term. Nine refers to Nines refers to how many nines are in the definition of your reliability equation, right? For example, 99.9% reliability is 3 nines, and 99.999% is 5 nines. Each nine adds a significant complexity and cost, and we'll talk about how that happens as we get deeper into the discussion. But let's get this really concrete. If we expect a system to process 9,995 of 10,000 transactions flawlessly, that would be 99.5% reliable, or 3 nines. On the other hand, if we expect it to process 99,999 of 100,000 transactions flawlessly, that would be 99.999% reliability, or 5 nines. The bottom line is the more nines means less downtime and higher reliability. So if we're trying to reach a certain level of reliability, how do we do that when we know stuff breaks? Well, code can be incredibly reliable, just churning through the same operation over and over and over. That code runs on a physical device that's subject to wear and tear at different levels. Since we live in a real world where stuff breaks, how do we account for that when we're trying to get to a certain level of reliability? The metric we use in this case is mean time to failure. It's an average time a system is expected to operate before a failure occurs, or an average number of transactions processed before failure occurs. It's a key metric for understanding system longevity and maintenance. Knowing the average time it takes for something to fail helps you understand how often in a given time frame you can expect an unexpected outage, or make conscious choice to replace something during planned maintenance before it hits that mean time to failure. Meanwhile, you could also think about MTTF as just a way to predict that your system might fail. So you can work proactively on maintenance and other things. A good example is typically in a sound studio like this, you're going to take the batteries out at the end of the day every day, even though it might last a day and a half, 2 days. We always start the day with a fresh battery because the mean time to failure is going to be somewhere in that next day, so we just don't want to mess with it. We'll always start with clean batteries. It's that kind of thing that helps us make sure that we get to the reliability we need for our equipment in the studio. While we might have an idea of the average failure rate of a system component, or even proactive maintenance to force failures at a predictable rate, that by itself doesn't define our reliability because recovering from failures takes time. The metric mean time to repair is used to describe the average time it takes to recover from a failure. This metric defines how long a system is unavailable for processing and therefore has a significant impact on the overall number of nines that you're able to get from the system. This metric drives a discussion about a different ability also, recoverability. I'll cover that in another video, but for now we'll focus on the fact that something with a lower mean time to repair is inherently more reliable. Lowering the repair time reduces the number of potential failed transactions, and therefore focusing on speedy recovery is a key component to improving the nines of a system. At the end of the day, your business owners and people that care about what's happening in your company's systems are actually probably more worried about something known as availability than reliability. Now, availability can be determined by looking at the reliability and the mean time to recovery. The best way to think about this calculation is if you use the mean time to failure and mean time to recovery, availability equals MTTF divided by MTTF plus MTTR. So I'll give you an example, something really concrete. Let's start with the requirement of having 99% availability, so 2 nines. If planned maintenance is every 4 weeks, then MTTF is 672 hours. If planned maintenance takes 5 hours, then MTTR is 5. So 672 divided by 672 plus 5 equals 99.3% availability. That gives you an extra 0.3% reliability, or about 2 hours of extra downtime every 4 weeks allowed by this reliability guarantee. Now, that's not much time, and that's only for 2 nines. It begs the question, what does it take to get to 5 nines? If normal systems get patches once a month, how can anybody get to a MTTF small enough to meet that? We'll be getting into that in later videos.